Welcome to part 2 of Angos Software's 3-part series on the credit scorecard development process. In part 1 of this series, we introduced the credit scorecard and discussed the first 2 steps in the process, data collection and data preparation. In this video, we will talk about variable selection, coarse classing, model development, and model validation. After having gone through the stages of data collection and data preparation, we typically end up with a very large number of variables, sometimes numbering in the thousands. For practical reasons, we will not actually try to use all of these variables in a model, meaning we will have to filter them based on which promise to be the most predictive. Having an analytic approach to reduce the variables and select those that are more likely to result in a scorecard is usually done using a set of measures of predictive power. There are a large numbers of predictive power measures that can be used to automatically, or through an algorithm, reduce the variables into a smaller set that now will be the candidate variables for modeling. Some of the typical predictive power measures that we use are chi-squared, information value, Gini index, and entropy variance. Manual inspection of the selected variable list may require adding variables that might have been rejected by the predictive power filter in order to make the scorecard depend on different sources of data and thus more robust. The analyst will need to make sure that these measures are not used blindly, as many strong variables are correlated and essentially represent the same information. Then, out of that reduced set, we begin to build a model that will select the final set of variables that end up as part of the actual scorecard. The next step is coarse classing, sometimes referred to as variable segmentation. Looking at one of the variables that we used in the sample scorecard from Part 1, annual income, we can see that it has been segmented into 3 ranges: less than $25,000, $25,000 to $50,000, and more than $50,000. These segments are not chosen arbitrarily. They have been selected such that they increase the predictive power of this variable as much as possible. If we look at the chart at the bottom of the slide, we see the default rate versus the segments. We notice that there is a slope that shows the higher the income, the lower the rate of default. We need to select the boundaries of these segments such that we maximize this slope, making it as steep as possible, thus increasing these segments' power in predicting customer default. This kind of segmentation is called optimal segmentation and is usually done using decision tree algorithms. Then, on the basis of these segments, we perform what is known as the weight of evidence calculation. While we will not dive into the mechanics of weight of evidence in this series, its mathematical definition is actually a fairly straightforward function. This process, including weight of evidence, is the heart of the scorecard and determines the entries in the final scorecard table for each attribute. Our ability to optimize the relationship between the default rates and the bins by the careful selection of these bins, or coarse classes, is the key to building strong scorecards. Once we have defined the weight of evidence transformation for all of the candidate variables, we can now construct the analytical model that will be the basis of our scorecard. There are different ways to build models. For example, we can build using decision trees, neural networks, linear regression, or logistic regression. Given we are focused on building a standard scorecard, the format itself requires us to use a combination of weight of evidence transformations and logistic regression. Because it is based on robust mathematical theory and variable evaluation statistics, the logistic regression model is perhaps the most used model in the various areas of data science, including credit scorecard development. Even though we have reduced the variables using the measures of predictive power in the previous step, we still may have a large number of variables that are part of the regression model. The value that logistic regression provides is that it can tell us the significance of each variable, how strong the variable is, and how important it is within the model. Logistic regression works by finding the probability of an event. In our case, the event would be that the customer or account will go into default. It can be written in a very simple formula in terms of odds. It is important to keep in mind that the odds are not themselves a probability, but a ratio between the probabilities of 2 events. If we were to say the odds are 50 to 1 good, payment to bad, default, a sample of 51 accounts would show 50 accounts have paid on time and that one has defaulted on their payment. In any modeling exercise, regardless of the application, we have to validate and test our model. In anticipation of this, we usually separate the data into 2 or 3 partitions. We build and fit the model on one sample, the development sample, and then we test the model and validate it on the other sample. It is not uncommon for the test and validation samples to be split up. We will not go through them in detail during this series, but there are several tools and charts that are used to assess the quality of a model by scoring the test partition and plotting charts such as gains, lift, KS, and ROC. These charts render a whole set of statistics and measures that help the analyst assess the power and robustness of the model. Thank you for taking the time to watch Part 2 of Angos's 3-part series on the scorecard development process. In Part 3, we will go through the final 2 steps, scaling the scorecard and deploying the scorecard. If you would like to learn more about scorecard development or dive into topics we did not cover in this video, like weight of evidence calculations and validation statistics, you can visit our credit scoring page on angos.com or download the How to Credit Score with Predictive Analytics white paper. If you have any questions about this process, scorecards, or predictive analytics in general, you can submit them through our website, and one of our experts will get back to you. Thank you for watching, and we look forward to seeing you again in Part 3.